see everyone's here. So good afternoon, everybody. Evening and perhaps morning for some of you people. So thanks for attending the webinar on monitoring approaches to modern overlay networks. My name is Dave Holmes. I'm the VP of Sales here in North America. First of all, I'd like to thank our North American partner, TestWorks, for working with Cubro and setting up this webinar, which will be presented by Cubro CEO, Christian Ferenz. As you can see, everyone is muted, and I suspect more people may come online. We ask if you have any questions during the webinar, just please enter them in the chat space, which we'll address at the Q&A period of the webinar. Obviously, if you have further questions, we can certainly have one-off discussions after the webinar. So thank you again for attending. The floor is yours, Christian, and thanks everyone for attending.
Okay, guys. Thanks for joining. So I want to touch today as a technical background. So we will try to help you to understand what is the challenge in this modern overlay networks design, what we see today in data centers and in providers and also in large enterprise customers. So we would touch a little bit the technical background, and then we see what our solution does. So okay. So what is the overlay network? Actually, overlays, this is not something new. We have overlays in the old days with MPLS. MPLS is actually also overlay technology. The issue today is we have more and more overlays. So we have customers, they run multiple hundred overlays in an underlay network, and this makes it pretty complex and to monitor the traffic. And the issue is that in the old world in MPLS, the overlay was pretty static. Nowadays, the overlays are highly dynamic, and this makes it extremely complex. So what is the overlay? An overlay is a virtual network running on an underlay network. This is a physical network. So, and you can run multiple overlays in this underlay network. One information you had to know is that typically underlay networks and overlay networks are not connected to each other in a way of management. So the underlay network don't know how many overlays are running, and the overlays are not knowing how many other overlays networks are. So this is fully separated from each other. So also from the management perspective. So this is the first challenge actually. So, and there are some different overlay designs. Yeah, you see 4 of them here now. And the question is now, everybody asks this question typically, why we need these overlays. And the point is, this overlay, why we need overlays is a technical background is because of the virtualization. So the virtualization comes with a lot of nice fancy features, but what happens with virtualization, we have thousands of endpoints. And I can tell you, we have customers with 10,000, 20, 50,000 hardware-based servers, and on top they run multiple thousand virtual instances, Docker or VMs, whatever. And the problem is now, if you have so many endpoints, then typically classical routing technologies will not work. So no router can handle this. So that's the idea of these virtual overlays. And these virtual overlays are designed, are invented by VMware and Cisco together. And VMware, because they produce these virtual machines, and Cisco, they had to do the routing, and the routing is not working in this million of entries. So the reason is they invented these virtual overlays. This is based on this VXLAN technology. You will see it in a minute what the VXLAN does. So and the idea is that for the underlay network and for the routers, such an overlay with multiple hundred instances or endpoints are handled as one endpoint for the underlay network, and that's the advantage of such a overlay network construction. So the other advantage is that typically these overlays are layer 2 transparent. So it's fully transparent, so you can use always the same IP address. So you use this 192 range because it's easy, everybody knows it. So typically what happens, you run the same IP ranges 4, 5, 6 times. This is nice and easy for the user of the overlay, but this is really bad for us, for monitoring people, and you will see in a minute why. So this is typically such an overlay design, and what we see here is I have made these 3 overlays, and these overlays use the same underlay infrastructure. So even on the same hypervisor, you can run different virtual machines and they can belong to different overlays. So this is pretty complex. And this is a very simple example, but typically you have multiple of 100 endpoint devices to deal with. So, and you see, I say it's layer 2 transparent, but this layer 2 transparency is a simulation. So ICMP or ARP and all these features, what we know from old network designs, are simulated by the overlay technology. So it's another issue for us. So if you make a trace route on such an overlay, you see the endpoints, but you don't see what is in between. You see only the endpoints because it's a virtual simulated network in a way. Okay, and you see, typically we have multiple of these overlays, and I told you already, in some cases we see multiple 100 overlays, not only 2. When especially in mobile operators, what happens today is typically if a mobile operator starts a new virtual EPC, then they always come with this overlay network design. And in the beginning, typically they say we only have one overlay. And if you have one overlay, then it's pretty simple. But what happens is very soon they add other overlays for IMS, for instance, or for Office LAN or whatever. So typically what we see today that even a mobile network is only a layer 2 overlay in a bigger data center. So and then the problems starts. So so to do the visibility on such an overlay network, so we have several options to do this. Visibility of the underlay network. So then visibility of a specific overlay network, visibility of all overlay networks, and visibility of everything. So a full end-to-end view. So I will talk now what is currently the standard. So what we do at Cubro is we still do really visibility. The other option, what many people do at the moment, and many of our big competitors do go this way, they do an endpoint visibility. The endpoint visibility is they added a little bit software on the devices and then they produce traffic. And many big players do this because they don't have our technology and they don't want to do it in our complex way. But the problem is with this endpoint visibility, you have the problem that you, especially for security, you don't have access to the packet. What you get is only metadata from these endpoint software devices. So, and it's not agnostic. So for each device, you had to do a separate software. So it's an option, but we think it's not the best option. Okay, so I did some explanation, the pro and cons network visibility to endpoint visibility. So for a service provider, they need 80% network visibility, maybe 20% endpoint visibility. Large enterprise customers 40 to 60. So, and enterprise customer with a public infrastructure, then definitely you don't need a full network visibility. Maybe 10% and 90% is endpoint. So that's the reason why we are focusing on service provider and data center providers. So if you have a customer then and they have a cloud infrastructure, it's their own cloud infrastructure, it's 50-50. Yeah? It depends what the customer really wants to achieve. But in the situation when you want to do really security monitoring, then you have to use the packets, and in this case you need a solution like ours to get really to the packets, because this endpoint visibility solution, they only give you metadata, not the real packets. So consider this. Okay, what is now really the challenge on such an overlay monitoring? So first of all, we have a lot of links to monitor, because everything is full meshed, and you see this in this picture. So typically you can easily have multiple dozens of 100 gig links, because today everybody does new designs in 100 gig. So we have customers, they have 50, 100 gig links in a data center. They are not fully loaded, of course, but they are installed only in 100 gig. And so you have a lot of 100 gig links, but you had to tap them all to get a full visibility. Sometimes it's also needed to tap here, or you can use sometimes spanports here to avoid tapping the last mile. But if you want the full end-to-end view, then you had to do this as well. So when we now tap on the physical layer, in that moment you see immediately the problem. The problem is because we see all the traffic at the same time. And if we are now in the unlucky position, and normally you're unlucky, you have multiple IP addresses and they are the same IP addresses. So let's consider we have 3 overlays, and most probably 2 of them have the same IP range. So what does this mean? This is really a nightmare, because the trick to remove the overhead and encapsulate the traffic will not work, because in the moment when you just remove the VXLAN, this is the tunnel technology in these overlay networks typically, then you mix the traffic, and in that moment all these techniques with capture, with net flow, all this technique is gone, because you mix the traffic. So this is a nightmare. So okay, but it could be even worse, because often these networks are spread over data centers. So these networks are spread over data centers, maybe also over countries or over the world. So these overlays can run over data centers. This is one issue, and the second issue is often data centers are sliced to have errors in the slices. So this data center, if you have a large data center, typically with multiple floors, typically the floors are separated logical units. And in between these logical units, they use PGP, this standard internet protocol, to transfer these points. And I showed you, I'm showing this picture, how this works. You have a VXLAN on one side, then you have a VXLAN, and between you have a PGP controlled WAN. So this means there's a VXLAN tunnel here, there's a VXLAN tunnel. They belong to each other, but they are different VXLAN tunnels. So it's you had to read the overlay. So if you now try to do this manually, of course theoretically you can do it manually, but it's a nightmare. Yeah, so it's a very big issue to correlate all the data and then do filters and so on. So it's definitely not a cool option. I jump over this. This is we share this slides with you later on. This is some technical background. Maybe we need it, but actually what this shows the frame structure of the underlying network. So this is the full frame, and this is the frame what we capture. But actually only this is relevant for us. So we want typically only monitoring this. this overlay information is typically useless. But as I said, when you have multiple overlays and these overlays are with the same IP address range, then you see it clearly. When I cut off this header, I mix the IP address, and this is a nightmare. And then you don't have any results. And we see this in customers. They feed this strip data to monitoring tools, and of course you get the result, but the result is not accuracy and not useful. And if you do a capture, you mix everything, and you have strange captures because you mix two different networks. Okay, so these are the scenarios what can happen. We have a lot of different scenarios. I will jump over this. You can read this offline. So the point is how we do handle such a solution. So what we do is we correlate a lot of information to get the end-to-end view of the traffic in a network. So our packet brokers producing S-flow. If needed, then we also do N-flow for statistics, but it's not always needed. But we also do PGP. So we correlate the PGP traffic, we correlate S-flow, NetFlow, this virtual distributed switch. This is the information out of the hypervisor. We do this virtual distributed switch is for VMware, or we look at the neutron interface if it's OpenStack. Then we do this PGP signaling, and then in some cases where it's needed, we look also in the original switch data from the customer so that we find that we can see behind the last switch. This is very important. You will see this in a minute why this is important, because if we don't look in the switch and correlate this information, if you have a legacy device connected to such an overlay, you will only see to the last switch, and sometimes this is not enough, because consider you have multiple hundred endpoints, and these endpoints are virtual, so you cannot troubleshoot them because you don't know where these endpoints are. So this is a big challenge for many of these operators. Okay, and what we do with this information? With this information, we correlate an end-to-end view. And this information shows you, this is my endpoint, this is my endpoint, and these are the ways how the traffic goes through the network. So with this information, we can, when we have NetFlow, then we can also give the customer a performance indication. So we can produce a health score, But beside of this, we use this information that we can automatically do filtering based on this dynamic VXLAN ID. So what the customer can do with our solution, he can say, give me the traffic from this overlay, and even when the overlay is changing, and even if the overlay is expanding or the overlay runs on different slices in the data center, we still are able to find this correlation, because what you see, we did here the PGP signaling. So the PGP signaling is a routing protocol inside the network, and what we do with this, jumping back to this picture, you see, so we have on one side, we have this VXLAN header, then we have the other VXLAN header. These are different headers. And in between, we read the PGP, and this gives us the connection. So we know, okay, this VXLAN and this VXLAN belongs to the same overlay. And then we do a filtering based on this information. The problem is really that these VXLANs are dynamically. So in the situation that this server goes down and the network switch to another server, it changed the VXLAN. So typically you cannot do this by hand. Yeah. Sometimes if you have only one or two overlays and these overlays are pretty static, then we have customers and we help customers to do this manually because they want to save some money. But on this situation, you can easily have 400, 500, 600 rules in the packet broker. And believe me, if this is IP version 6, it's not a funny situation to enter 600 rules, even with Excel or any scripts, and to prove the 600 rules. This is a nightmare. Yeah? So it's not a cool thing to do this by hand. So this is what we're doing. So we give you the end-to-end view. This is just an output, so you see, okay, there are some different outputs how we do this. Yeah? And then with this information, you see really how the network is configured at this time. And the second problem of these overlay networks, if you do troubleshooting and you get a ticket and say, okay, this is not working now, then you had to have an option to look back in time, because the ticket is maybe produced 4 hours ago, and 4 hours ago the network looks different than it looks in this moment. So if you now troubleshoot the network, you see, the network is working fine, so close the ticket. No, the problem is 4 hours before the network was differently configured, and typically you would not see this. We give you the option that you see, you can go back in time and see how was the situation 4 hours ago, and then we give you the configuration of the network, and then you see, and then you can use this for troubleshooting. Yeah? So this is one advantage of this technology. What we also can give you with this idea is we can point to the hardware interface in the switch which is not working. And this is the reason why we had to look in the metadata of the switch, because if on this port is a legacy switch connected and not a virtual environment, so this legacy switch does not give us any information. So that's the reason why we had to look in the switch, in the top of the rack switch, and read out the information out of the switch, and then we combine this information, and then we have really an end-to-end view, and we know, okay, where's the problem? Where's the physical problem? When you consider, we have customers, they run large, big overlays, and they want to do a full capture. Then they say, okay, let's use spanports on the top of the rack switch to do capture. The problem for these guys is only they don't know on which top of the rack switch the virtual device is currently connected. So it's not easy to do a spanport and do a capture. Most probably you don't know the correct switch. So this is a big issue. And when we show this to customers, then they love this idea, because with this technology they find the right switch and they find the right port where they had to do a spanport or adding a capture tool to see what's going on in the network. Yeah, we come with some features, because often distributed firewalls and distributed logical routers, this is another add-on what we had to do to see the full picture. So, and then you have some statistics. Yeah, we give you also statistics out of this information. So it's not only that we filter the traffic, and this we provide also this metadata. And this metadata is very useful for troubleshooting. Yeah, you see here these are the tunnel endpoints, and with these tunnel endpoints you see how much traffic is flowing. And if you see there's a missing traffic, then you can calculate and see, okay, I missed some traffic, or there's some issues. And of course you can drill down, and then you see really the connection inside the tunnel. You have the endpoint ID, and then you have the ID, the IP address of the really physical endpoint. In this case, a lot of VMware machines, and then you can drill down to every connection. So you see, and the same, and we do the same metadata what we generate for the monitoring. We do this and feed this information to our controller, and with this information, the controller has the ability to filter dynamically each overlay network. This is typically very important when an overlay is dynamically. Then you can change. Then you can follow the service. Yeah, and the next step is the idea. For instance, especially for mobile networks, when base stations or new devices are assigned to a network, then typically the monitoring people don't know that this happens. And we see this assignment before we see traffic. And then we can forward this meta information to the monitoring device and offload the monitoring device, because the monitoring device can then easily correlate the information based on our metadata. This is also very important, especially for 5G, when you have multiple 10,000 base stations in the future. So you cannot do this manually. So what the trend is currently, the trend is that it's network automation, and because it's network automation, we need also visibility automation. So these days of doing visibility by hand, adding some filters, this time is definitely over in large environments. In small office environments, of course, you will have this for the next 10 years maybe, but in large data center environments, in large enterprise customers and in operators, this manually configuration of visibility tools, this is over, because you have too much. I can tell you this from our daily work with customers, multiple hundred rules, and the change is so often, so that customers running after their traffic, and the monitoring tools are not working because monitoring and security tools are not working because they don't get the correct traffic. This is a major point. And the point is, when many of our competitors, they don't have the capability to do VXLAN filtering, and they don't have the technology to do this correlation. But what they do, they offer, okay, let's remove the VXLAN overhead. But as I mentioned, in this case, you mix the overlays, and then the result of your capture is useless. Okay. So, and these are really examples how we do this in larger situations. So we put a lot of packet brokers, and we have customers where we have 50 of these boxes in the network, and we are tapping really every network, and then the packet broker are feeding this to our controller, and then we do this correlation, and then we read out the data out of the network infrastructure, and then we have some other boxes where we feed the traffic in, and then we support to send the right traffic to multiple monitoring systems. It's not one monitoring system. We have many customers, and easily you can have, in operators, you can have easily 10, maybe 15 different monitoring systems. And in the old days, they did everything separate, but this is a cost factor. And with this solution, we can give the customer really a segmented visibility for each service. So the security people will only look on the management traffic, and the mobile people will look at the mobile traffic. And some office people, they will have maybe performance measurement tools. So, but all these services running today in one big network. It's one data center, and with many overlays, and everything runs on the physical infrastructure. So our visibility approach must be that we had to separate all these different services. And the challenge is really to do this dynamically. So because the service are changing. So we must read the service changes, and then we had to adjust our filters. This is definitely needed. But also this has an end at one point. And that's the reason why we developed since 2.5 years our Cubro Cloud Switch. The Cubro Cloud Switch is something fully different. If maybe 5 years down the road, we will see cloud data center, large cloud data centers, and everything runs in the cloud, especially with 5G, then most probably everything runs in the cloud. And at that point, this classical way of tapping traffic and do this, so this hybrid solution, what we currently have, this will end. Because you have so many ports, you have so much traffic, so this classical approach will not work. So we think in this time, it's not now, but we have already customers who are using this, but it's not now, and it's not a mass. But we will think that the future is that the visibility must be a part of the network infrastructure. And what this cloud switch does is actually a full featured fabric switch. So we do all the features what the fabric switch does. Actually, all these boxes, what you see, these blue boxes, they work actually as one big switch, to understand it more easily. And we put the visibility on top. And the advantage of this is because we know what the switch is doing, so we don't need to do this complicated correlation, because we know already that, because we are part of the network infrastructure, so we know what's going on. In the hybrid solution, we had to reassemble all the information and build our map. In this case, with the cloud switch, we look in the system and we are part of the system, so we know easily which application is running where. And what you see, this is a cloud application. This is available today. So if you go to Airbnb or Facebook, this application, this is not one monster application. So this consists of multiple 10,000 microservices. And these applications are breathing. This is not the case currently in the telco environment, but it's in the cloud environment for Airbnb and this, or Booking, and all these big applications. They consist of microservices, and these microservices are breathing. Means if there's high load, then they start automatically more microservice applications. So when we have a login service, but when multiple 10,000 customers want to log in, so they run then 500-600 of these login microservices, also for load balancer and things like that. So you see, the application is breathing. In the morning, not so many applications. In the evening or in high times, we have 10,000 endpoints to monitor. And now you see, this is not possible to do this by hand, because nobody knows exactly how many devices are working at this time. Currently, this is really for the big guys at the moment, but we see more and more of these applications coming up. So even a telebanking application will look like this even today. So if you go to a bank or bigger companies with these big web applications, you will see the same design today. So, and in this case, what we can do now filter not on an IP address, because this is not relevant anymore. We are filtering not even on a tenant ID. The tenant ID is the virtual machine ID. So what we do, we are filtering really on the service ID. So this is layer 6. Yeah? And what we do, we use the network infrastructure to forward this filtered traffic over the existing infrastructure and feed this in a tunnel, in an VX tunnel, and we feed this to a virtual or a physical monitoring, capture, whatever solution. Yeah, we think visibility will be always needed, but we think visibility had to be a part of the network infrastructure. So this idea with virtual pubs, this turns out this is not working. You know, the performance is poor. It's too complex. So we think visibility will be a part of the network infrastructure in the future. So this is actually the end. I would say the cloud switch is a little bit far away for us at the moment. We have already customers. We have a very big cloud provider in Asia Pacific who runs. We have sold 500 of these units to them, and they run this in a large data center. And we learn a lot with these customers. So this is a friendly customer. So this is a development project. So it's still under development. We can do 90% of the requested features what the Cloud Fabric currently does, plus some additional feature for the visibility. But this is definitely, we think this is the future. Yeah, this is the future for our business, and that's the reason why we put a lot of effort in this technology. It's to make visibility also possible in the next few years. Okay, I think I hope it was not too fast. Yeah, maybe we have some questions what we can answer now online. Please raise the hand.
Hey, Christian, that was awesome. Thank you. A lot of the folks on here are all the people that we know. I don't know why some of the other folks didn't get on. So, but Bjorn, you there? Hey.
Hello?
Does Ramon work with you in the Netherlands?
Yes.
Okay. Yeah, that's what I thought.
Yeah. So, but we can do this. We can do this a second time. Maybe some guys are missing the invitation. I'm happy to do this again. So it's not a big deal for me to tell the story again. So
no, it's great. And I like to find out. Some of the people that I know that were gonna come on. I'm gonna try and find out if something happened with the invite or what it was. So I'm not really sure. But okay.
Maybe WebEx is not working in their region. I think in the last days we have also issues here in Austria to connect to WebEx.
Someone actually messaged me and said they couldn't log on, but for some reason I think it's more local to them. So I did have one message. Yeah. Okay. Well, thanks. I don't suspect anybody has any questions. Kath, you?
Okay.
What we'll do is we'll follow up with the people and get some feedback. Maybe they weren't available, but perhaps there's something with the invite that they didn't see. Command and I will talk about it as well. So.
Absolutely.
Okay. Well, thank you very much, and I appreciate you taking time this evening.
Thank you. Thank you guys for joining. See you.
Yeah. Thank you. We'll talk soon. Okay. Bye-bye.
Bye-bye.